Today we're going to talk about the change of base rule. Now, this isn't something that comes up very often, and we've touched upon it a little bit, but let's talk about it in a little more detail. So the change of base rule is that I have the log base b of a. I can really rewrite this using any log base that I want and call it log c of a divided by log c of b. And I always remember that the base goes on the bottom, and that's how I remember the order, that the base always has to be in the denominator. So if I have something like log 4 of 12, which I can't evaluate, I could actually rewrite this as the log 4 of 12 equals x. This is just proving to you that this change of base will work. I can write that in exponential form, 4 to the x equals 12. If you remember from when we were solving equations, you could take the log of both sides. I'm going to bring the exponent down, and I'm going to take the log of both sides. And if I'm solving for x, I have x equals the log of 12 divided by the log of 4. So you can see that this actually proves that this change of base actually is true. So if I have the log 15 of 73, I could actually just rewrite this as the log of 73 divided by the log of 15. Now I could use any log I wanted to, but since the log base 10 or the common log is a button on my calculator, that's a convenient one to use. You could use the natural log if you wanted to. It really doesn't matter. So let's evaluate some expressions using this change of base rule. So I have the log base 7 of 8 divided by the log base 7 of 16. Well, we know that I can actually, since the base goes on the bottom, I can actually write this 16 as the base of my log and then have this as the log 16 of 8. Since the base goes on the bottom and the log I chose doesn't matter, I can rewrite this as the log 16 of 8. Why this helps me is because now I can evaluate this log, and this log would be 3/4. Again, the base doesn't really matter. I could have the base be anything because I could rewrite this as the log base 25 of 5. Again, the base has to go on the bottom. And why this helps me is I can evaluate this to 1/2. Put this on pause and see if you can evaluate this one on your own. All right, so you can rewrite it as the log base 9 of 27, which can be evaluated to 3/2. So this is one way that we can use the change of base rule to help us evaluate logs. Another way is if we have two logs that are multiplied together. We had learned from our law of logs that if the base and the number switched, then I could evaluate them, and it evaluates down to 1. But that's not the case here. So I can rewrite the log 8 of 25 as the common log 25 divided by the common log 8. And I can rewrite the log 125 of 4 as the common log 4 divided by the common log of 125. Now if I change 25 to 5 squared and 4 to 2 squared and 8 to 2 to the third and so forth, I can then go ahead and put their exponents back. So log 25 becomes 2 log 5, log 4 becomes 2 log 2, log 8 becomes 3 log 2, and log 125 becomes 3 log 5. Now I can cross-reduce. Since these are multiplied together, I can cross-reduce, and you see that these log 5s actually cancel out. Same thing with the logs 2, they actually cancel out. So I'm left with 2 times 2 in the numerator and 3 times 3 in the denominator. So this will help you evaluate this expression to 4/9. All right, put it on pause and see if you can work through this one. All right, change each one of these logs into their change of base rule. So log 5 over log 36, log 8 over log 25, log 6 over log 4. When you can, write them in exponential form and then put the exponent down front, and then cross out any of the logs that can be canceled. Log 5 can be canceled, log 6 can be canceled, log 2 can be canceled, and you end up with 3/8. Same thing will work with variables. I can write the log C3 of A as the log A of 3 times log C. The second log here I can write as the log 4 log B divided by 2 log A. And the last one is log C divided by 5 log B. Cancel out any of the logs that can, so log A's cancel out, log B's cancel out, and log C's cancel out. And I'm left in the numerator with 4 over 3 times 2 times 5, which can be reduced to 2/15. If you have any questions on this, please let me know.